Hello everyone, I'm Dan Guo from Hefei University of Technology. I'm going to introduce our work for Visual Dialog. The Visual Dialog task is a vision and language task proposed in CVPR 2017, which aims to develop an agent to hold a meaningful dialogue with humans. The agent has to answer the question based on the image and history. The challenge existing in the visual dialog is a visual and textual coreference resolution. It requires the agent to understand a series of multimodal entities. As questions usually contain pronouns, for example, it, they, she, it has to interpret pronouns and some abbreviated sentences. After that, reasoning about the relations among these multimodal entities is helpful for answer prediction. For relational reasoning, the graph structure is a good choice. This is our proposed graph network. To infer a reasonable answer, the process can be divided into three steps. Firstly, the graph construction step builds the fine-grained multimodal context nodes. Secondly, the graph inference step iteratively learns the relations among the nodes and updates the graph structure. Finally, the graph embedding step aggregates the whole graph semantics for answer prediction. For graph construction, we use fast RCNN to extract object features and denote them as visual context. And question conditioned attention is applied on the history to obtain textual context. We use both visual and textual features on each node to deeply comprehend the dialog content. We propose an adaptive top-K message passing mechanism to iteratively exploit the context representations of the nodes and update the edges. Each node adaptively chooses its top-K relevant neighbors, and it only receives the message from these neighbors to update the relation in the graph. Taking object 3 in the image as an example, our model aims to imitate human reviewing multimodal cues many times for answer inferring. In each iteration, our model first attempts some operative words in the question. Then each node will discover relevant neighbors related to the question. Finally, the positive relations among the nodes will be activated by message passing. As questions usually pay attention to a small part of the objects in the image, here we apply a graph attention to pick up more relevant nodes for answer. There are two graph-based models for visual dialog, except for different graph structures. Previous graph models adopted fixed graph learning frameworks, such as fully connected graph and fully message passing. In contrast, our model explores a dynamic graph learning by adaptively directed message passing. Experiments verified the effectiveness of our model. Here we display two examples. The relation graph progressively changes in each iteration. After multi-step inference, our model can find out implicit question-related semantics for answer prediction. The other example is the attentive word cloud. The model first attends the pronouns and locates the subjects and finally tries to discover other information such as attributes. The whole dynamic graph inference process is human reasonable.